All right. Hello, everyone, and welcome to our first webinar of the year, organized by the World Bioenergy Association in collaboration with Bioenergy International. My name is Alejandra León, and I'm part of the WBA Secretariat here in Stockholm. And the session today will be focused on modern renewable heat using biomass for industrial processes. But before delving into today's session, allow me to provide a brief introduction to the World Bioenergy Association for those who are not familiar with our organization yet. The WBA stands as a global industry organization dedicated to supporting and representing all the range of actors within the bioenergy sector. Our mission is clear: to promote the sustainable development of bioenergy through international advocacy and by serving as a platform for sector engagement. Our members include other bioenergy associations, research institutions, and companies along the entire biomass to energy value chain across the globe. And for those who are interested in joining our community, the membership offers several benefits, including opportunities to participate as a speaker in different bioenergy events, like this one, to join the WBA delegations, to high-level forums, to access to member-exclusive publications, involvement in working groups, and to support the advocacy efforts promoting sustainable bioenergy at different levels. Now, returning to today's session, it's important to know that this is just the beginning of our spring series. We have 2 more sessions scheduled for April and June, and the details for registration can be found on our website and social media channels. Before starting, remember that you can ask your questions through the chat function, and the recording of this session and all the presentations will be available for you on our website and YouTube channel. You will receive an email with more information later on. And now, without further ado, I leave the floor to our moderator today, WBA President Christian Rakos. Thank you. Christian, the floor is yours.
Thank you. Thank you very much, Alejandra. Ladies and gentlemen, I'm very glad to see that a lot of you are joining our webinars again today. We're touching a very relevant topic, and that is the use of bioenergy in industry. Industrial energy demand is a significant part of global energy demand. And if we think about decarbonization, we need to also think about how to decarbonize industrial energy use. And bioenergy has a lot of advantages, most importantly, the advantage that this is stored energy that can be supplied upon demand, and that is not fluctuating with the availability of sunlight or of wind. And today we're going to have a number of distinguished speakers that will give us first an overview. Manolis Karampinis from Bioenergy Europe will give us an overview on what kind of industrial applications there are and where he sees important possibilities for bioenergy. We will then pass on to Justin Tate from Enviva, the largest pellet producer of the world. And he will give us a number of interesting examples of large industries that are thinking to use bioenergy. Thomas Schmidtmeyer is a hero of the first hour of bioenergy use in Europe. He has spent, I would say, almost his entire professional life in promoting the use of bioenergy in industrial applications of medium size. And finally, Linda Löfhagen will give us a very specific example of how to use bioenergy in the asphalt industry. So with this setup, with this lineup, I think we'll have a very entertaining and interesting hour. And I will pass the floor now to Manolis Karampinis from Bioenergy Europe.
Thank you, Christian, for the introduction and for the invitation. I hope you can hear me well. It's a bit ironic that we are in this webinar for the industrial applications while I'm on my way to Verona for the project of Focofer, which is the other side of the bioheat, the residential bioheat. But it happens sometimes, so you have to take things on the move. 1 second until I can share my presentation. Can you confirm that you see it in full screen mode?
Not yet. Yet.
It's fine?
Yes.
Okay, perfect. So for today's webinar, I thought I would speak a bit more about the high temperature heat applications for biomass or other industrial applications, rather than the low and the medium heat applications. I think other speakers are going to cover the topic a bit more in detail. Before I go into the meat, a few words about Bioenergy Europe. We are, like WBA, an association. Our focus is European rather than global. We've been around since 1990, representing the bioenergy sector in the Brussels institutions. We are a members-based organization. We have as members around 40 national associations and around 140 companies from all steps of the bioenergy value chain, from fuel producers to traders, equipment providers, and end users. Some of them now actually belong to the industrial segment I'm going to speak about today. We are hosting the European Pellet Council, a network of pellet associations in Europe, and we are involved in two certification schemes, one on fuel quality, EN+, and one on sustainability certification, SURE, to conform with the requirements of the Renewable Energy Directive. And what we are doing is first and foremost EU policy monitoring and influence. We are active in collecting data from the market, but of course, like every association, to promote, make our members more visible and so forth. And what we are usually doing internally in Bioenergy Europe is organize activities within working groups. We have 7 of those. Some, I would say, are a bit more market-oriented or feedstock-oriented, like the pellets and agro-biomass. Others are more policy-oriented, and the policy topics of priority at the moment are sustainability, the very hot topic of carbon dioxide removals. There is, I think, the 3rd webinar of WBA is focusing on that, and also industrial competitiveness, which covers carbon taxes, Net Zero Industry Act, and many other policy files. If you would like to hear more about this, feel free to reach out to me later. And when time comes, we are also involved sometimes in EU projects that allow us to expand a bit our horizons or knowledge of the sector. And we have been recently involved in 2 projects which are related to the topic of this webinar. REF4 Industry, which was about renewable energy utilization in energy-intensive industries, and MUSIC, which was about thermally upgraded biomass feedstocks. I would invite you to take more information, to look for more information on the project websites, because there is a lot of material over there. For today's presentations, I rely mostly on material we have developed within the REF4 Industry project, so I still have to acknowledge it. About bioheat. Talking about focusing on EU for the beginning, we know and we usually tell that bioenergy is the largest renewable energy source in Europe, and most of bioenergy is actually consumed in the form of heat. But of course, there is also presence also in the electricity generation and the transport sector, but this is beside the point of today's presentation. And if you look at the bioheat consumption in different sectors in Europe, the residential sector is about half of it. About 20% is derived heat, so district heating, but the industrial sector takes up already today 25% of bioheat consumption. So a big part of biomass is already being used in the industrial sector. When you look now at the temperature levels at which biomass is used and how it compares with other feedstocks, you will notice in the diagram on the right that biomass is mostly used for temperatures between 100 to 100 degrees in industrial applications. It has a presence in higher temperatures, above 200 or above 500 degrees even, but at the moment, not so much compared to natural gas or even coal or other fossil fuels. I would dare say there is a reason for that, and the reason has to do with which industries at the moment are actually using biomass more. So if you look at how biomass is used within the industries, the ones that are typically using biomass to cover the energy demands are industries with biomass residues or wastes of their own. So the paper, pulp, and the printing sector has, of course, their own residues, the wood processing sector the same, and the food sector is similar. So if you take another approach of looking at the European industrial sector, you can differentiate between 2 segments. One industry segment with access to own biomass residues and wastes. And there, what you can find is that bioenergy already covers 25% of the total energy consumption. And you have another segment which is unrelated to biomass, dealing with minerals, with metals, where biomass at the moment only takes up 2% of their industrial consumption. But that might well change in the future, because that pressure is also in pressure to decarbonize. How much are we talking about? Just to give you an idea, these are data coming from on the left from the EU ETS, and you see that the bigger, let's say, polluters of carbon dioxide in the atmosphere within the EU is production of iron, followed by cement production and mineral oil. These are the big, I would say, polluters. And also interesting is if you look at the diagram on the right, which is a bit complicated, it shows a bit how the industrial distribution, the industrial emissions are distributed across different components. So the heat generation component is an important part. But it's also relevant to note that many of industrial applications generate what we call unavoidable process emissions. For example, because of the calcination of limestone in a kiln. And the process emissions is a major issue, and the reason why I call these hard to abate industries, because you cannot control them by a simple fuel switch. You need other solutions, such as application of carbon capture and storage. That being said, the fuel switch is a major part of the energy transition for those industries. And today I would like to give you some examples of how some of them are looking into biomass utilization. And I will start with the usual suspect, which is the cement industry. Cement industry is a high temperature application. It requires significant energy consumption, around 3.7 gigajoules per ton of clinker produced, and it reaches temperatures about 1,500 degrees. If you take note of the European cement production, which is 183 million tons in 2022, and multiply this by the energy demand, you can take a guess of how much energy you need for cement production. As noted before, 60 to 65% of the emissions in cement manufacturing are unavoidable process emissions, but the remaining is mostly fuel related. A small part is electricity driven. So for the cement plant, switching to a carbon neutral fuel is a major step on the road to carbon neutrality. And already today, we have individual cement plants which go almost to 100% thermal substitution by alternative fuels. What is relevant to note is that these plants typically use low or negative value biomass feedstocks. So things like animal meal, sewage sludge, waste wood, green waste, and pretty much everything with a biogenic carbon content that someone wants to discard, and instead of ending up in the landfill, would go into a cement kiln. If you look at the roadmap of the industry, by 2050, the European Cement Association estimates that 90% of the fuels used in the cement kilns in the EU are going to be alternative, of which more than 50% is going to be biomass. The pictures I have here are from a cement plant in my native country, in Greece, which is using already now and starting to use more and more green waste coming from public parks, from urban tree management, as a substitute for fossil coal. A very interesting sector for the bioenergy world is lime. Lime has also high temperature levels, a bit higher energy consumption. If you look at the total EU lime production, it's not the same level as cement, of course, but it's a very relevant material used in many different applications. Noticeably different between lime and cement is the size of the industry. In cement, we're talking about fairly big plants. In the lime sector, we have multiple smaller lime kilns in almost all EU countries, and most of them, I would say, are small-sized companies with some exceptions. This has some implications when it comes to considering, for example, bioenergy supply chains. Again, we have the unavoidable process emission component, which requires that the lime industry employs CCS solutions in the long run, but the fuel switch is already part of their strategy. In September or October last year, the European Lime Association published a pathway to a negative emission sector by 2050. Fuel switching is mentioned. And if you look at the graphs, biomass is already expected to be 1/3 of the fuel mixture in the lime kilns in Europe by 2030, and it will retain this percentage already all to 2050. So in total, we estimate that perhaps the biomass demand that could come from the lime industry is around 2 million tons, and already now there are lime kilns even to 100%, but usually these are located in the southern European countries, smaller and using locally available biomass resources. An industry I like to talk about a bit is magnesia, because it's a niche industry, but it also showcases some of the limitations that we might run up to when we're considering the biomass use in those industries. So magnesium is also very versatile mineral used from all applications, from animal feeding all the way to refractories for steel mills. And there we have even higher energy consumption and extremely high temperatures in some products. The production in Europe is concentrated in a few countries. Again, the process emission component, and up to 2016, we had, at least officially, no biomass use reported by the sector. Again, in Greece, we have one major initiative. A company called Grecian Magnesite is already using different types of biomasses to substitute petcoke in their magnesia kiln. The issue with the magnesia industry is that because of the very high level temperatures, the standard biomass fractions that you typically use don't always have the pants to reach the temperatures that you require, unless you consider torrefied biomass materials. In any case, the sector as a whole targets 10 to 30% biomass use as part of its emission reduction roadmap for the future. Steel is another very interesting case, but already here we're steering away from the pure temperature applications and more into metallurgy and chemistry. The steel sector is using fossil carbon as a redundant, about 58 million tons estimated in 2021 in Europe, and secondary, I would say, as a heat source. The steel industry has two main production pathways: the blast furnace, the more traditional one and a more polluting one, and the direct iron reduction with lower demand for fossil carbon. The long game, I would say, in the European steel industry seems to be a switch from blast furnaces to DRI production methods. But until we get there are going to be blast furnaces in operation for sure, and we are already looking into projects that aim to substitute fossil carbon by thermally processed biomass. The principle works. We know that it takes place, for example, in smaller furnaces in Brazil, where charcoal is replacing coke even to up to 100%. But this is easier to do due to mechanical properties. In the bigger blast furnaces of Europe, at the moment, we are talking more about biotar or torrefied biomass, which is substituting what we call the pulverized coal injection. Not going into all the technical details, by 2050, we could have a demand of 10 to 17 million tons of biocoal, which goes to an impressive 60 to 90 million tons of biomass. And it's also relevant to note that we have other metallurgical industries, for example, manganese alloys, which are also looking into thermally processed biomass fractions as a replacement of fossil carbon in their own processes. A few words about the chemical industry. There are two ways in which biomass could be used there. Perhaps this will be discussed later on. One is the standard method of producing steam from biomass. This is a well-known and proven technology. Whenever you have steam demand, you can do it with biomass. So I would say this is a low-hanging fruit and already taking place. We have examples of soda ash production using biomass instead of coal. But the other pathway is a bit more elaborate, is then using biomass as a feedstock for carbon. And there you can have different types of intermediate products like cleaning agents, deciding fluid, and so forth, but it's a bit more complex pathway. Not taking up too much time, some outlook. I didn't discuss about scenarios in this presentation, but I would say most of them agree that biomass and bioenergy would have an increasing role in the global, even the European sometimes, energy demand in the future, with an increasing emphasis in hard-to-abate sectors, which includes industrial heat. I should emphasize that biomass and bioenergy is usually not the only option for the fossilization of the industrial heat demand, but we also expect that other energy carriers, other solutions like green hydrogen, electrification, and CCS or CCU are also expected to play a role. Bioenergy is well established in the wood and the food processing sector, so the sectors that already have access to biomass resources. It is currently used in small volumes in other sectors, but I would dare say it leads the race in maturity and cost effectiveness because it is already there, it exists, and it can work cheaper than other solutions at the moment. In the long run, it will be employed in application where it provides a competitive advantage over the other solutions for the industries, because at the end of the day, also industries want to make money. And when it comes to the prospects for industrial bioheat, I would say they depend on several parameters. One, for example, is the market development. You have to consider the price of fossil fuels and the EU ETS price, so the carbon prices compared to biomass. But you also have to consider the specificities of each industrial site, things from space limitations, access to local biomass resources, access to logistics infrastructures, and sourcing options. And of course, you have to consider the process that you employ in your industrial process, whether you need simple steam or whether you need something more elaborate that requires that you pre-process your biomass to a certain quality or characteristics level. And in all cases, and this is the role of Bioenergy Europe at the end of the day, is that you do need an enabling policy framework for biomass and bioenergy to unlock its potential. You need clear rules on biomass sustainability, but also on how you can use it in industrial setting. And I think that's enough from my side for now. Thank you.
Thank you very much, Manolis. So that was a beautiful overview of what can be done. And I would like to pass on the floor now to Justin Tate. You are directly in contact with the potential industrial users of biomass. Enviva is the world's largest producer of pellets. Please, Justin, give us your views and introduce your work to us.
Okay, thank you, Christian, and thank you, Manolis. Let me just get this set up so you can see it. Okay, you see that okay?
No, it's the we now see the view of the speaker. So we see your view, but not the presentation mode.
No problem. I will swap that over. There you go.
That's fine.
Okay. Thanks, Christian, and thanks, Manolis, for a great introduction there and a good overview of some of the sectors where we are certainly seeing demand for biomass that we produce in the form of wood pellets. So my name is Justin Tate. I'm our Director for Responsible Sourcing at Enviva. And I think as was already said, Enviva is the largest producer of wood pellets globally. Part of my role is to work with our market development team and to support them and work with customers and potential customers and markets on understanding what we do as a business in terms of sustainable responsible sourcing. But that also then means I get involved in discussions with some of these new use cases, and hence why I'm here today. My colleague Jens Wolford is also very heavily involved in this area, but he's in Copenhagen this week, or CMT. So I'm going to take us through this presentation. So just give me a second. Okay, so Enviva, as I say, is a producer of wood pellets. We have 10 production plants in the Southeast US, shipping out of 6 terminals. And that's predominantly into Europe, the UK, and Japan for our customer base. So Manolis is focused as Bioenergy Europe in Europe, but we as a business are much more globally focused. And we have a capacity to produce, nameplate capacity around 6.8 million tons of woody biomass in the form of wood pellets. We have offices in the US, but also here in the UK, and in Berlin and in Tokyo. I think, probably don't need to say this, but I think we all know that the IPCC and the IEA and many others recognize bioenergy and biomass within that as key to cutting emissions and reducing our reliance on fossil fuels and addressing some of the harder to abate sectors, including with BECCS, which is clearly a focus for some of the traditional power generators right now, is how they develop bioenergy with carbon capture and storage. This is what we're talking about, the humble little wood pellet here on the left-hand side. Manolis has already touched on some of these sectors on the right-hand side where we see future uses for biomass, and we'll cover a few of those where we're already involved in a moment. But you can see the characteristics of a wood pellet make it suitable for quite a big range of potential applications, given the right technologies, logistics, and support mechanisms. And some of those can be a challenge for really actually taking some of these potential uses to realization. And I'll touch on some of those as we go through. So I think Christian said at the beginning that what we get from bioenergy and biomass is the ability to produce heat or power as a renewable fuel, even when there isn't the sufficient sunshine or wind, for example, for solar and wind power. I mentioned at the beginning, we traditionally focused on replacing coal, so that's really in power stations for power generation and heat and combined CHPs, where we know there's a proven case to use biomass and an ability to reduce GHG emissions significantly, 85% compared to coal, 70% compared to gas. But and most of our existing customer base is gone through that journey, either converting an existing power station, which is a fairly efficient thing to do, or in the case of Japan, where they've invested heavily in building new plants to replace nuclear power and making bioenergy and the use of biomass a significant part of their portfolio. So as we move across this kind of graphic to the right-hand side is where we see the discussion and the potential for harder to abate industries that Manolis was talking about, and to reduce the reliance on fossil fuel within those value chains, and for woody biomass to become a serious sort of part of a wider bioeconomy. And some of those areas where we have had conversations with potential off-takers for actual feed, for biomass feedstock, include the process heat, certainly for lime and cement, and Manolis mentioned a couple of those examples. We have existing contracts and supplies into Europe for some of those applications that began last year. We have lots of conversations around the steel space, some challenges there, technology challenges about getting the right kind of heat out of the pellet, and whether torrefication is a route to do that. But there's also lots of other industry and chemical applications, and we'll come on to some of those for refining into green crude and green crude into things like SAF and to marine fuel. I think the closest term ones that we're working on and we already supply into and have set up contracts with alpha lime producers. And I think those are good and working, but I think there are some challenges around logistics. If we think about our traditional logistics, they're huge, they're big volumes into ports, into a single site power station. And once you have that infrastructure set up, it works, it's fairly easy to manage. I think with some of these newer applications, particularly lime, we have smaller plants, more plants spread out across a greater geography. So the logistics for wood pellets need to be established as getting smaller volumes into smaller plants and smaller uses. So that creates some challenges for us, but definitely doable and something that we already do. Steel, I think, again, transportation does become an issue there, but also is thinking about what's the material use. Does it need to be torrefied? How do we do that at scale? We don't do that ourselves at the moment. Lots of people have asked, are we thinking about doing that? But the answer is right now we focused on what we produce right now, which is a white wood pellet. But there's plenty of opportunity there, I think. A really interesting one, of course, and is the SAF space. Lots of potential feedstocks and feedstocks already in use for SAF, but woody biomass is one that we have had many conversations with, signed initial offtakes for. We don't have supply chains operating right now into that space, but agreements to do so if the refining capacities are built. It's potentially a massive market. Of course, woody biomass can only provide one pathway or one feedstock into that to that demand. There needs to be many others to be able to meet the size of that market. But I think it's a really significant one, and I think with the right regimes and incentives in place, and there are, certainly in the US now with the IRA, the Inflation Reduction Act, it's really sort of starting to kickstart some of those investments. There are some challenges in the way that SAF is certified in different markets in the US versus Europe, in ICAO standards and versus regulatory standards and mandates. So I spend quite a lot of time talking to stakeholders around what it means to produce, how we produce that woody biomass and how it can fit with regulatory regimes and certification schemes, or how some of those schemes should think differently, particularly about woody biomass compared to biofuels, which is what a lot of schemes are traditionally built on. So some challenges to still work through on that side. Methanol for shipping is again a really big potential marketplace. A lot less incentive right now and mandates, etc., in place to make that happen in the way that SAF is beginning to happen. So I think a definite need in shipping, and I think biomass and feedstocks there is a great opportunity, but there just isn't that kind of pull right now from the market, because I don't think the right kind of mandates are in place or drivers to make it happen, as I say, in the same way as SAF. And for us, it's, as we are focused globally in terms of markets. There's on this little graphic here, you can just see some of the examples of where we've working in different applications, cement, lime, and biofuels, and having discussions around some of these other issues, things around steel and in different parts of the world. And I just want to talk a little bit about, so we talked about the applications quite a lot. I think the sort of the supply side is interesting to think about for us as well, and for this huge potential for bioenergy. A lot of the questions then come back to, well, where's all this material going to come from? And I think that's it's an ongoing question, and it depends on where the demand eventually ends up being. But certainly for us in the Southeast US, as a producer and a part of the forest products industry there, we already know that in the Southeast US, there is lots of potential for further use for some of these applications for the feedstock types that we work with. The US is a huge area of working forest. The forested land in the Southeast US is bigger than that of Sweden, France, Finland, Spain, Norway, and Germany combined, as you can see on this little graphic here. It produces around 1/6 of the world's wood products. Predominantly, the forest products industry is focused on much higher value, lumber and sawmilling timber, but goes through a whole range of OSB down to pulp and paper, and then at the kind of the lower value, much lower value end of the market is bioenergy. In terms of an inventory in the Southeast US, we've seen the inventory of forest in the Southeast US continually increase. And you can see the example here is based on data from 2000. So the makeup of that forested area in the Southeast US is probably predominantly small family-owned plots of forest. And a healthy market creates a healthy incentive to continue for them to invest in growing those trees and being a participant in that market. So we provide an important part of the market for a landowner. He will always want to sell his timber to a higher value market, to lumber, for example, but there is always going to be timber and residues from those harvests that are suitable for bioenergy use. And that's where we come in. There's also a changing dynamic across the Southeast as well. So there is a reduction in some areas for sure, and generally in the demand for pulp and paper. So there are spaces, if you like, for thinking about how the sector can grow, or how these growers can also be benefiting from the market for future uses and applications of bioenergy and materials that would have perhaps gone to a pulp and paper mill that no longer exists, has an alternative outlet. For us, what we want to see is those family farm and landowners continuing to invest in forestry and reforesting and seeing regeneration in their forest lands rather than conversion, which is in certainly something we don't want to see as a business, and we will not source from anywhere that is going to, where a landowner says, I am going to convert this into agriculture, housing, or commercial development. So I think, having that important market and these potential growth areas is a big part of that story for us. We talked about the challenge for local logistics, but what we do already have in place is the ability to, and the supply chains for global movements of biomass, and for us, and movements of wood pellets around the globe. So lots of experience in already moving those from the Southeast US across into Europe or across into Japan, and thinking about how when we work with third-party suppliers, part of our business, we also do work with third-party suppliers, thinking how you then access that supply and take it into other, Southeast Asia, for example, or move cargoes within Europe to service those different needs. And I think we're starting to build up some experience in developing and partnering with organizations that can help us with the internal logistics in the EU, where we're less familiar with those challenges. I'm going to leave it, I think, at that point there. The only other slide I had in here, we haven't really touched on the pricing, but we did some work last year to think about the competitiveness of wood pellets specifically versus other fossil fuels when you take into account carbon pricing and projections on carbon pricing. Now, of course, for those customers thinking about lime in the lime industry or cement or steel, that's exactly what they're doing. They're thinking about where are my costs going to be related to carbon, and fossil fuel prices is an important part of the equation for the case to move to a bioenergy source or a biomass source. And the carbon element of that is clearly very important. So, any questions?
Thanks a lot. Thanks a lot. I think we'll collect the presentations and have the questions at the end of the presentation. So I would like to ask Thomas Schmidt now to share his views. Thomas has been very much into using biomass in smaller scale industries than Justin, you have been talking about. So Thomas, give us your experiences with renewable process heat using biomass, please.
Yeah, thank you, Christian, and warm greetings from Bavaria in southern part of Germany. I want to show you some of our projects in smaller scale businesses and in not used to use biomass businesses. Our typical customer is producing, for example, gummy bears or stuff like that, and not wood panels or paper or whatever. So the projects we are doing is normally far away from knowing what to do that or how to do that and how to deal with biomass. We started 15 years ago with smaller projects where we made steam from pellets. That was the smaller systems up to 3.5 megawatts in that container systems. We call it Klimaschutzzentrale, and we have some more projects of that. But what we've learned in the past is the projects are getting bigger and bigger, and there is a 2,000 kilowatt project was typical 10 years ago. Today it is a very small project for us. We work between, let's say, not 500,000 and 25,000 kilowatts. We are doing a lot of CHP projects in Germany. We do never produce electricity from wood in our projects for bringing it into the grid. Our customers are using whatever they are producing in their plants directly. We are doing it in a special way because we're no boiler producer. We are a little bit untypical, something between project finders, sellers, engineers, project engineers, and we build it up. We have our own stuff to weld all the pipes and stuff like that, and then we help the customers with wood supply, with ash deposit and stuff like that. And we always say we are getting friends for lifetime with our customers. In Germany, we have the situation that the government knows that biomass has to go a little bit away from that low temperature heating in grids, in smaller villages. What we can do in some years when we have enough electric power with electric power, and we can store warm water for a long time for district heating. What we are not able to do when we use steam in a plant, and this is why our understanding is the biomass has to turn and has to be leaded in that market with medium temperatures between 110 and 500 degrees. We have some projects now where we are higher than 500 degrees, but not too much higher. But this is where we think the biomass should be in steam production, in production of temperature levels we can't store, not even for 15 minutes. All that amount of energy we are producing in that plants is needed between the next minutes when we are producing it. That's very important. Our fuels, as I told you before, 10 years before, it was pellets most of the time. And then we changed to residues, to cheap stuff, to material which has high ash contents, problems with ash melting points, and so on. And this is what helps us today, because the political landscape in Germany has changed completely. And in Berlin, all the politicians are thinking that we have no wood, absolutely no wood, there's no wood, and we need all the other stuff to burn it. That's not correct, but this is what they think in Berlin, and this is what helps us in our projects. And with subsidies, in Germany, they are only willing to finance projects where you are working with used wood, with residues, and that helps us because this is what we are doing 90% of our time. We have different systems to burn wood. You can see this ACF, ACR, ACRP, that is the air-cooled stuff, where we just we have just a cooled grade, no firebox cooling, and this is the difference to LCR, LCF. This is the systems where we have a cooled firebox, which helps us to avoid melting ash and all that problems you can see in boilers which are using high caloric fuel. This is what we are doing every day to cool the fireboxes to avoid ash problems, ash melting problems. This is a typical project. with a small steam turbine, and we are using here the warm water to provide a plant. In different projects, we are using the steam in front of the turbine, or we are using the steam in the middle of the turbine to produce something, and the rest goes into energy production. That is this first year's projects with pellet silos and systems up to 5 tons of steam. This is the maximum what you can transport on German highways. 3.9 megawatt furnace capacity, 5 tons, 4.5 up to 5 tons of steam. This is the maximum. And when we have bigger projects, we change to special constructions. We deliver that complete. So we need no other companies to work in the same place, and this is what our customers want. One phase, and somebody who solves all the problems in a project. I have some projects now and some lessons learned after that for you. This is the newest one, a very big pharma producer with a brand new plant in Bavaria. They invest up to 500 million euros in making that plant bigger, and we supply a steam boiler with 6.4 megawatt firing capacity, 12 bars, and it runs nearly full power the whole year. They will supply 40,000 megawatt hours per year, and this is not a typical project for us because they are using wood chips and only wood chips for forest residues, no used wood, and nothing more than material from forests, which is untypical. And we are doing that as a main contractor. We supply the building, everything complete with the boiler, and we help them to run it. And we founded a company to supply them with 70,000 square meter of wood chips per year for the next 10 years. This is the biggest vegetable dryer in Germany. Steinicke is the company's name. We installed a 9.3 megawatt boiler last year. We make 25 bar there, which is a very high level for us, but it is prepared for using a turbine later. This system was built in a time where the subsidies in Germany did not allow steam turbines in that project. So we prepared it, and in some years that customer will install a turbine. It's prepared for it and will install a turbine and will produce energy for his plant too, not only wood. And it's 100% used wood class A1 and A2, which is not the very poor quality. It is with paint, with plastics on it. That is no problem, but no quicksilver and not the very poor stuff. This is a greenhouse project, 15 hectares of greenhouses in Bavaria, where we supplied 2 boilers. The first is installed and is running. It's 6.8 megawatt warm water boiler. All our boilers are from Kolbach. And now we install a second one for superheated steam together with a turbine. Now it is allowed. And we use the steam to run a turbine. And then we go with warm water after the turbine into the greenhouses. And they are needing used wood and forest residues together. Both is permitted there, and we can do both in that plant. This is a new project. It's in commissioning in that week. In next week, it's ready now, but we have no better pictures than that one here. Fire capacity is 10.4 megawatts. It's built for used wood class A1 and A2. They will save 11.3 million of CO2 per year with that plant, and it's the world's biggest producer of, I don't know the English word, it's beer heavy, whatever a brewery has as a residue after having made the beer. This is used here to do very high level food for pets and so on. This was a very small project in Scotland, whiskey distillery, 1 megawatt boiler capacity, just wood chips from forest residues near the plant, installed and commissioned 2017. That is a new project for a Russian company, Europe's biggest malt producer with 4 plants in Germany. And we start here in Bremen to build a 10.4 megawatt boiler for them with superheated steam 22 bar, 300 degrees. And we will make their steam for the process and energy for the process too. And they are using just used wood class A1 and A2. That is one of our oldest projects, installed 2014, 100% industrial wood pellets, 2.5 megawatts. It's installed and run since that time without any problems, without anything we had to do there, and very successful for the customers. They won a lot of prizes Europe-wide for that laundry. This is an interesting project because we are producing more than 500 degrees there to dry quartz sand for different industries. We have a second order now for a much bigger plant, nearly 10 times bigger. They are drying 1 million tons of sand per year there for making metal stuff for motors, and the sand is sent out in nearly the whole world, whole Europe minimum. And both projects are using used wood class A1 and A2 too. And I think this is one of the last projects. This is in Nuremberg, where we supply glass houses too for a farmer, and we supply the whole Nuremberg airport. You can see it on the picture behind. That is supplied completely with heat in the winter time to heat up the buildings. From that two systems, it's 2 times 5 megawatts. And Christian Rakosch asked me for something like lessons learned. And the lessons we learned in the last some years was the projects are getting bigger and bigger. That means you have to handle more money, more value, which is not too easy for a family-owned business. We are 70 people. And I learned in my life the most important thing you have to do when you are growing fast and when you are dealing with big projects, no bankers' money, no investors' money, just your own stuff. That is the most important thing for us, and we are very proud to be able to do that in that way. The customers are getting more and more bigger and more professional. So you can do a handshake for 10 million euros with a vegetable farmer like this one in Nuremberg is one of them, but you can't do that with a pharma company working worldwide. And we are dealing sometimes 10 months for a contract to be ready and to sign it, which is a huge problem for a small company. We hired lawyers now, and that needs a lot of time from us to negotiate all that contracts. The projects are getting more and more complicated in Germany. We have a lot of permission problems in our country with burning wood, and what we learned is it's getting more and more a business for specialists, not for boiler producers, because it's too complex and too complicated for boiler producers. You need to be located in one country to concentrate on that and all the things you have to know in that country. And it's not possible to do what we are doing so deep and so wide. Then we are working with the customers together in different countries in the world. I think that's not possible to do it perfect then. And what we learned too is you have to work as a general contractor to be successful, because whenever you have foreign companies involved in that plants, it's getting complicated. You have to do thousands of emails and telephone calls, and we work together all times with the same companies, and we learned that it is less risky, less complicated when you do it on your own, but you need to be perfect in whatever you're doing, and you know what you have to do, and then you can be successful in projects like that. And I think the most important thing we learned during the last 2 years was that biomass is more and more seen as a limited source in Germany. There is a lot of climate protectors who are fighting against us, and this is where all the people we have in that call and in that session have to stand together and to fight against them, and to make sure that we can use biomass as carbon-free fuel in 10 years in Europe again. That's it. Thank you very much.
Thank you very much, Thomas. So a wide range of different projects that you have realized. It's interesting that you're noting that you have actually parted from taking high value wood towards used wood or other residue materials. I have been trying to follow up the chat. There is a lot of discussion going on in the chat, and a recurring question has also been on the use of agricultural residues. Do you have specific experiences with agricultural residues, and can you comment why most of your projects are based on wood?
Yes, most of the projects are based on wood because we have no ash melting problems. We have no problems with too much silicates in the stuff, and we have seen that things like straw are not cheaper. They are more expensive than wood, and all that used wood stuff. In Germany, we have a price for used wood with today, I think 35 up to 40 euros per ton, which is less than 10 euros per megawatt hour. we are telling our customers, don't deal with agriculture project when you can find wood for 50 or 60 or 70 euros. You don't need to deal with agriculture project. And I can say that because I'm a farmer. I was grown up at a farm. We harvested thousands of hectare straw 30 years ago for other projects, but I know what that means to produce 1,000 tons of straw and to transport it to one place and to make sure that it don't get wet in the winter time and so on. Wood is easy and it works and it runs.
Thank you very much. Now let's go to our last speaker, Linda Löfhagen. Linda, your company, NCC Industry, is involved in using biomass for asphalt production. Can you show us how you're doing that and why you're doing that?
Yes, delighted to do that. Let me see. So, can you see my screen?
Absolutely. It's still not in
Okay.
presentation mode.
Put it in presentation mode. Is it good?
Yes, thank you.
Great. So, okay. My name is Linda Löfhagen, and I work as environmental manager at NCC Industry Division Asphalt. And as already said, today I'm going to talk to you about asphalt production using wood pellets as fuel. So this picture might be a little bit misleading since we don't use wood pellets in our paving industry, but we do it in our asphalt plants. But I have so many pictures of asphalt plants that you will see during this presentation. So I started with this one instead. So we are a construction company and we are based in the Nordic countries, and we are divided into 5 different business areas. These are NCC Industry, NCC Infrastructure, NCC Building Sweden, NCC Building Nordics, and NCC Property Development. And the business area NCC Industry is divided into 2 divisions, Division Stone Material and Division Asphalt. So at Division Asphalt, we develop, produce, and sell asphalt products in Sweden, Norway, and Denmark. So here in these countries, we have 51 stationary asphalt plants, and you can see them here as small dots. This is the life cycle of asphalt products, and asphalt consists mainly of crushed stone materials, but also of this product binding agent called bitumen, which is produced from petroleum or crude oil. And if at the end of the life cycle, you can see the life cycle here in the picture, at the end of waste, if the asphalt pavement is brought back to the asphalt plant, it's recyclable for 100%. So we can recycle all the asphalt pavement that is brought back to us. And asphalt production is super energy intensive. We use a lot of energy. We use 7 liters of diesel per ton asphalt mix that we produce. And only us at NCC produces around 5 million tons of asphalt per year. This corresponds to 342 gigawatt hours. But I have a problem to understand these figures, so I tried to put them in a context. So this corresponds to 4.6 days production at the Swedish nuclear plant, Forsmark, or driving a Tesla for 163 million kilometers. Or if you want to take the same Tesla to 2,036 round trips to the moon. Anyway, still hard to for me to understand the amount of energy, but I do understand that it costs a lot of money. So in Sweden, we have no taxation on biofuels since 1984. And we also have this special carbon tax on fossil fuels since 1991. This is, of course, a large incentive for us to reduce energy consumption from fossil sources, but also to change for renewable energy alternatives instead. And this is one of the reasons why we at NCC started to convert asphalt production to wood pellets. So in 2012, our first asphalt plant was converted to wood pellets. And in 2016, we had worked out this patent for using wood pellets in asphalt production. 2019, our first Norwegian asphalt plant was converted. And in 2020, all our Swedish asphalt plants were already converted to biofuels. But because of the different taxes and different availability of the fuels, we have traditionally used different fuels in our asphalt production in all our countries. And when we started to convert to wood pellets, we had some major challenges with this. For example, I'll try to explain some of them. Here you can see a schematic picture of an asphalt plant, and you can see the dryer. This is the drying drum, and to reach complete combustion with wood pellets, we had to expand the drying drum and make it larger, longer. Another problem we had is handling and the logistics of the wood pellets, because we can't use it as it is. Of course, we have to mill it into a powder, and then we have these explosion risks and so on. So there were many things that we had to find a solution to. And this is also why we were so happy and proud when we could develop this patent for operating our asphalt plants using wood pellets. And it is extremely important for us to do this also, since this reduces our CO2 emissions enormously, because in the life cycle of asphalt materials, most of our CO2 emissions occur in the beginning of the life cycle. You can see here the life cycle modules A1 to A3, and they are, and in the diagram, you can see the emissions from these modules. If we use fossil fuel, LFO, we have emissions for these three modules for 34 kilograms CO2 equivalents per ton asphalt mix. But if we instead change to wood pellets, VP here in the diagram, we reduce our emissions to 14 kilograms per ton asphalt mixture. So it's a significant reduction changing to biofuel instead. And we also have requirements on us from, for example, the Swedish Transport Administration. We have reduction requirements on production stage A1 to A3. And to declare our CO2 emissions for these life cycle modules, we are obliged to declare them in an EPD. This is an environmental product declaration. This document is it's third-party verified, and it presents environmental performance of a product from a life cycle perspective. And we publish all our EPDs at environdec.com. So you can go in there and find them yourself and see all our CO2 emissions and other emissions from the asphalt plants that we have in Sweden. This is a picture of one of our asphalt plants, and here you can see where all the reduction measures takes place. And you can divide them into 3 different categories. So we have energy optimization, cutting the use of fossil fuels, and saving natural resources. This here in the middle of the picture, VMA stands for warm mix asphalt, and LTA is the Swedish words lågtempererad asphalt. This is a technique that we use to reduce temperature by 30 degrees. We already talked about biofuels, but it's the most important measure we have. And RA, that stands for recycled asphalt. As you might remember, I told you that if all the asphalt payment is brought back to the asphalt plant, we can reuse it into new asphalt mixtures. This initiative, BioBinder, is fairly new, and it's to replace the fossil-based bitumen by a biobinder instead. And in this diagram, you can see the effect of the different measures, or some of the measures. The bar to the left is traditionally produced asphalt, which means that we use only fossil fuel to produce it and only virgin materials. And you can quickly see that the largest effect is if we replace the fuel by biofuel instead. At the NCC, we use wood pellets or top. Top is bio oil. You might already be familiar with tall oil pitch. But of course, the most important thing is to combine all these measures to achieve the largest reduction. Here is the emissions that each fuel, according to our generic data sets that we use in our EPDs, these are the emissions from each fuel. And the darker blue ones, the darker blue or bars here are the fossil fuels, whereas the lighter blues are the biofuels. And of course, we don't calculate the combustion of the biofuels. So these, since there is an uptake from nature, and but these emissions are because of the production of the fuels. So here we can see that there are some things still that can be done to reduce the CO2 emissions from here. So to sum up, the primary measure that we have to reduce our CO2 emissions from asphalt production is to convert to a biofuel. But in Sweden, we have already converted all our asphalt plants. So that's good. But now that instead for 2024, the target is that 95% of the energy in asphalt production should come from a biofuel. This can be compared with 2015, when the proportion of biofuels was only 53%. And in Norway, we intend to convert all our asphalt plants. And today, we have already converted 4 of them. Yeah, that's it.
Thank you so much, Linda. Beautiful presentation, and I feel a very impressive picture of a company that is taking decarbonization seriously. So congratulations to your achievements. And I think today's presentations gave a very lively picture of how diverse the possible applications are, even though I should say our examples were pretty much Eurocentric. And apologies for that, because yes, indeed, in other countries, there are other resources. There are countries where there is not such an abundance of wood as in Northern Europe, for example, where the whole countryside is covered with forests. And in these countries, other biomass can play an important role. So I think what we eventually need to also include is, where can biomass from other residues than forestry residues or processing residues or recycled wood be used in order to supply industries with sustainable fuel. I think what we also learned is that things are more complicated than people think. Thomas made that very clear. Doing these projects is a complex business. It's very important to have specialized operators to really realize these. And even in your case, Linda, you had to learn a lot, I guess, to be able to really engage and now come to a level where you can almost you have almost zero use of fossil fuels. So there is a lot to be learned, and I hope today's webinar was a good occasion to learn for all our participants. Thank you very much for joining us. I'm not going to go into the chat, because the chat was actually, there was people answering to each other. So most of the questions in the chat were answered by other participants in the chat. We don't have to go that in the plenary here. So, and the time is over anyway. So thanks very much to all our presenters. It was a very interesting view of the diverse aspects of using bioenergy in industry. And I hope it was useful for our spectators. So all the best, and hope to see you in one of our next webinars again. Goodbye.
Thank you, Christian. Thanks to the audience as well.
Thank you. Bye-bye.
Goodbye. Thank you.